Hello everyone, my name is Ali, and in this series of videos we are going to talk about the blockchain. What it is, what kind of problems it is designed to solve, how it works, and what you can do with it. That is, what are the types of applications that are good candidates to use the blockchain. This is our first video, and we are going to see how absolutely easy it is to write programs that connect to the blockchain if you use the right tools. Let's call this video episode 4, onboarding of the blockchain magician. Let's start. We are going to start with a bare minimum TypeScript project that runs in the node.js. To do that, we create an empty folder and then use the command npm init-y to generate the npm or node project, which is basically a package.json file. And I open it in my favorite code editor, which doesn't open. There we go. So our package.json file it doesn't have any dependencies or scripts yet. So we are going to add TypeScript and TS Node. TypeScript is the official TypeScript compiler, and TS Node allows us to run TypeScript code in the node runtime. So we will create a TypeScript file and create the usual hello world, or in this case hello blockchain program to make sure that our program works. We will run it using npx ts node and the file name. There we go. Now we are going to make some read-only interactions with the blockchain, with the Tezos blockchain. And to do that, we need to install a Taquito library. This time it's installed as a runtime dependency, not a dev dependency. Next step is to create an instance of the Tezos toolkit. And we are going to pass to the constructor the address of a Tezos node. I'm going to pass the ghostnet node run by the ECAD labs. And now this Tezos toolkit instance gives us access to many of the functions that Taquito library provides. So it has a field of type Tezos provider, and that one has a function named getBalance. Okay, Copilot is giving us a random address. Let's hope that this address exists in GhostNet. And getBalance returns a promise to a balance, which is a big number to us. We need to convert it to a number, and then we see that this account has 23 million mu-Tez, which is micro-Tez. For the next step, we need to send some operations to the blockchain, and to do that we have to sign them. So we are going to install the package taquito/signer, and then we need to create a signer that the Tezos toolkit will be using to sign the operations. And what we are going to do is to create an instance of the in-memory signer. I'm going to change my code from the normal callbacks into an async syntax. So I'm creating an async function, and then we will create an instance of the in-memory signer from a secret key. Okay, so Copilot is creating suggesting some secret key for us. Let's hope it's not someone's exposed secret key. And then the signer can infer the address, which is basically the public key hash, from your secret key. So I'm going to run this code to see what address we get back. Okay, our secret key was not a complete secret key. I'm going to copy a secret key that I have generated earlier. Yeah, it was too short. So yeah, we get this address from that secret key. The next step would be to set the signer of our Tezos toolkit into this signer. And now this instance of Tezos toolkit can send operations to the blockchain. Operations that originate from this, that are sent from this address. And we are going to just do a simple transfer to another address. Again, this address is suggested by Copilot. And we are going to send 100 mutes. So as you see, Copilot is suggesting to send this operation. We don't need to send it because we are using the contract API of the Tezos toolkit. And the next step usually in our code is to make sure that this operation is included in the blockchain. So we are going to wait for the confirmation of this operation to make sure that it is successfully included. So now if our code gets past this step, it means that everything has gone right. And because this is a transfer operation, we can check our balance before and after this operation and see what is happening. So the rest of the code that I'm writing is not the code that is required to do this operation. These are just to see what's happening. And okay, I'm bringing the numbers first so that they are better aligned when printed, and printing the initial balance, the final balance, and then we are going to print their difference. Anyway, so in real code you might not use an in-memory signer because it's not as safe as using a dedicated signer that is remotely working from your code. This code that we are writing right now, it's a node process, not the usual in-browser app. We are going to show that in the next video. Okay, there's a mistake here. So you see we sent 100 microTez, but our balance change is 415, and the rest of the difference is due to all the fees, all the costs of the operation, like the fee or gas limit or storage limit, or let's say gas cost and storage cost. And we can check our operation on TZKT to see what are the details in our operation. Our next step would be to see how we can use Taquito to call an entry point of a contract. Instead of deploying our own contract, which is not the subject of this tutorial, we are going to use an existing contract, and a well-known contract for that purpose, which is a contract deployed by object.com. We are going to use ghostnet.object.com because we don't want to do anything on the production mainnet. And object.com is an NFT marketplace. It allows us to create collections and then mint NFTs in our collection. So what I have already done is I have created a collection and made our address, the one that we have set up the signer for, a contributor to that collection, which means that our address can send mint operations to our contract. What we are going to do is we are going to mint NFTs in this contract. I have already minted 5, so let's see how we can do that using Taquito and TypeScript. I'm going to remove the code that was specific to our transfer. So these 4 lines of code are the ones needed to set up Tezos Toolkit and our in-memory signer. And the first thing we need to do is to get the information about our contract from the blockchain, which is done using contract.at method. It gets the address of the contract and returns us an object that contains information about the contract. So object.com deploys or originates a new contract for each collection, and to see what entry point our contract has, we can use TZKT, well, again, ghostnet.tzkt, and our contract has quite a few entry points, but we are interested in mint artist. So let's call this entry point. Taquito provides 2 abstractions to call entry points. One is method and another one is method objects. And then I'm going to use the second one because it's more obvious how to pass parameters to this one. I suggest you do the same. And this entry point expects 4 parameters. So I'm going to, we already know what our collection ID is, and then this parameter is how many editions of the NFT we want to create, which will be only 1. So this metadata includes all the data that is required to mint the NFT, and usually it refers to some data that resides on the IPFS, and finally the target that receives this NFT. And as usual, we need to make sure that our operation is included on the blockchain. Let's call our contract's entry point. So we can go back to Taquito and check our operation. As you see, it is already included in the blockchain, and therefore our NFT should have been created. Let's go back to object.com. You see we already had 5 NFTs in this collection. So it takes some time for object.com to pick up the newly minted NFT. So I give it yes. So we see now we have 6 of the same NFT because we use the same metadata. Well, I think it was pretty easy to write code that connects to the blockchain, right? That's because we are using a good abstraction. And with this abstraction, you don't have to think about all the various things like cryptographic techniques used to sign the data, or estimating the costs, or encoding data in a format that the blockchain understands. Instead, you write minimal code to set up your library and then focus on your business logic. In the next video, we are going to create a dApp that runs in the browser. Stay tuned for our next video.